here are the solutions for the units 1 through 6 assignment. And my hope is that you first try it and then press play and keep learning and make a choice to learn rather than the choice to copy. All right, there's my little speech. Determine whether the following functions are even or odd. And there's a quick informal way to do this. Plug in a positive number into the function. Plug in the opposite to that, which would be -1, and then evaluate it. If they evaluate to the same answer, then that's an informal way to know that this is an even function. If these answers were opposites, then it would be odd, and if they don't match at all, then it would be neither. For number 2, if I use that informal way to do it, if I plug +1 in, I get 2. If I plug -1 in, I get 1/2. And so I'm looking to see, do they match? Are they opposite answers or neither? So you can see for number 1, it was even, and number 2, it's neither. For number 3, can you find the domain and range for this interesting looking square root function? So step 1 is I'm actually going to factor it. So x squared take away 9 is x plus 3, x subtract 3. That's called the difference of squares. And I'm going to draw a number line for the domain restriction. So the x values I'm interested in are -3 and +3. That's what makes the function 0. And I'm creating intervals to see which interval is positive, because the square root of a negative number is imaginary, would not be a part of my domain. So if I take an answer that's negative, so let's say you plugged in -4, what would happen? So -4 plus 3, -4 take away 3 is a negative times a negative. That's a positive answer plus 2, and that's all I'm really looking for. What intervals are positive and which ones are negative? Pick a number between -3 and +3. So take 0 and do the same work. So if you plug 0 in, you get a positive times a negative, and that gives you a negative answer. So the square root of a negative number is imaginary, and so we don't want the interval that's negative. Plug in a number greater than 3, and if you plug in +4 or any number bigger than 3, you get a positive times a positive, so that is a positive interval. By doing the intervals, you can see where the domain exists and where the restriction is. So the domain exists from -infinity up to -3. And -3 is included because you can take the square root of 0. Also, the next interval goes from 3 to infinity. And again, 3 exists because at 0 it exists. Between -3 and +3, it's imaginary, and there's the restriction. The range, if you think about it, the square root of any number, the smallest number this could be, the smallest answer this could be, is 0. So if you went 0 plus 2, the smallest number for the range is 2, and it goes to infinity from there. So the square root of a number, the smallest answer it could be is 0, and then add 2 to it. So the smallest altogether would be 2, and it goes to infinity. There can be no answer that's smaller than 2 for this function. Number 4, can you evaluate a limit? What's the limit as x approaches infinity? This is a right-end behavior question. So to understand it, you can finally just find the limit of the power over the power. So on top, the most powerful term is 3x cubed. On the bottom, the most powerful term is -5x cubed. The x cubes divide out, and you could see that it's approaching -3/5. So when it's approaching infinity or negative infinity, look at the power term over the power term to get your answer. Here, find the limit as x approaches 2 from the right. This is a substitution question, so plug 2 in, and because you can have an answer at +2, that is the limit. So at its most simple, a limit is a substitution question, unless doing a substitution creates something that is undefined. So +2, the answer is 0, not undefined, perfect. Notice in this situation, plugging in +2 makes it undefined, and it's impossible to remove it. So when you plug in 2, it's undefined. Therefore, this limit does not exist. You could also think of it this way, that at positive 2, we have an asymptote. If you plug in a number bigger than 2, that would be the right side. So if you plugged in positive 3, I want you to notice you get a negative answer. So that means the right side of the asymptote goes to negative infinity. But both are good answers. For number 7, we have a piecewise. And to understand a limit is to understand this, that if it's approaching 0, what it equals when it gets there does not affect the limit at all. Scratch it out. So this is considered the left side, and this is considered the right side. If left equals right, the limit exists. So in other words, plug in 0 on top, plug 0 on the bottom. They agree. And so both the left and the right agree that they are both approaching positive 1, so therefore the limit exists. At 0, the answer is 0, but it does not affect the limit. Scratch it out. And number 8, can you evaluate a limit off a graph? What's the limit as x approaches 1 using this graph? So notice where 1 is. Go to the graph. The left and the right agree that it's approaching 2. I want you to notice that the whole has no effect, because what the y value is when it gets there does not affect the answer. So what is it approaching is the power of a limit. So both the left and the right are approaching 2, and that's the answer. When it gets there, it's undefined, but that's not what a limit is. Just like when x approaches 2. Find where that is off the graph. The left and the right both agree that the answer is negative 1. Knowing there's a hole there, or that there's a point underneath, has no effect on the limit. So the y coordinate agrees. The right and the left are approaching negative 1. That's our answer. The limit would not exist if the left and the right are approaching 2 different y values. Then you would say it doesn't exist, because the left and the right don't agree. All right, on to number 10. For number 10, I want to graph that function, and I'm going to analyze it and then sketch it. To find the domain, all you do is look at the denominator. So x cannot be 0. So 2x gives me 0. Positive 2 gives me 0. And positive 3 gives me 0. Next, I'm going to reduce this down. I don't know why I put a parenthesis there. I'm going to reduce this down. This does not mean the color red. It means reduce. So is there any factors that can be removed? So x plus 6 cannot be removed. X subtract 2 removes the x subtract 2 in the denominator. So these simplify, and I have the exponent 2 after they simplify. In the denominator, 2x remains. X subtract 2 has been removed. And then we have x subtract 3 squared. I want you to notice that we have removed a factor in the denominator, and so the restriction that's connected to it creates a hole. So we have a hole at positive 2 that got removed. If you plug positive 2 back into the function, 2 subtract 2 is 0 times 0 divided by whatever. 0 times anything divided by anything. This answer is going to be 0. That means what is left in the denominator are vertical asymptotes. So 2x, the restriction is 0 and has an odd exponent. At the next restriction, which was positive 3, that's the other vertical asymptote, and it has an even exponent. The x-intercept is at negative 6. It has an odd exponent. X subtract 2 created a hole, not an x-intercept. There is no y-intercept because we have a vertical asymptote over the y-axis. So at x equals 0, there's an asymptote. There are no points on the y-axis. The end behavior is a limit question. In this case, what's the limit? Both the positive and negative infinity are going to agree. So if I take the most powerful term on top divided by the most powerful term on the bottom. So if I go x times x squared, the most powerful term on top is x cubed. In the denominator, 2x times x squared. would give me 2x cubed. And then the x cubes divide out. And both the left and the right approach 1/2. Another way to write this is there's a horizontal asymptote at y equals 1/2. And for symmetry, if I plug in +1 or -1, there is no symmetry here to worry about. Okay, now we're going to put all the things down we found. So we have a vertical asymptote at 0. We have another vertical asymptote at 3. We have a hole at 2, 0. And we have, there it is. We have a horizontal asymptote at 1/2. And it really only affects the end behavior. It doesn't affect anything in the middle. So the right end and the left end are going to approach that. We also have x-intercept at -6. Now we're going to put the graph together. So I know it crosses over at -6. And I know at the hole, it's even. So notice the hole has here where the hole comes from is an even exponent. So I'm going to start and find and look for +4. And what would happen if I plugged in a number to the right of the first intercept there? I could also start here to understand it. Maybe this would be easier. What would happen if I plugged in -5? Would it give me a positive answer or a negative answer? And then I could see how it crosses. So -5 is -5 plus 6. And -5, that gives me a positive answer on top. -5 times 2 is negative times a positive answer, which is negative. So altogether, I know at -5 is a negative answer. So I have a good sense of where this is going. So it crosses over at -5 is a negative answer. So this is the direction it crosses over. At a vertical asymptote, it can either go up forever or down forever. So when it crosses over, it's going to go to -infinity. At the first vertical asymptote, it's odd. So that means that one end, this end goes down forever. That means the other end must go up forever. The behavior at the hole is even. So as it approaches the hole, it's not going to cross over. It's going to touch the hole and then go back up again. And again, the behavior at the vertical asymptote is either going to go up forever or down forever. So it's not going to cross over at the hole. Don't worry that it crosses the horizontal asymptote. The horizontal asymptote is only for the end behavior. In the middle, it can definitely touch and cross over. At x equals 3, it's even, which means on both sides of x equals 3, they go in the same direction. So if this goes to infinity, this goes to infinity, and then it curves and the right end behavior approaches 1/2. So a very complicated looking function. And to be able to understand this function, we have to understand asymptotes, holes, intercepts, and understand if it's even or odd. It helped to understand at -5, it's negative, so I knew how it crossed over. And then once I started it, then the rest of the puzzle got put together. Number 11. There's number 11. Find the average rate of change. That's just the slope between 2 points. So in this case, it would be 7 take away 1 and 5 take away 1. So in other words, y2 minus y1, x2, subtract x1. That's 6 over 4 or 3 over 2. For part B, the word instantaneous rate of change is another word for derivative. So I'm going to take the derivative of g at x. So I'm first going to write it calculus friendly. So I'm going to write it to the exponent 1/2. Then I'm going to take the derivative for the instantaneous rate of change. Make sure there's a hook on of 4x at the end. So this is the power rule, and subtract 1 to the exponent. And there's a hook on of 4x. And the derivative at 1, 1, I only need the x coordinate. So I'm going to just plug in the x coordinate and simplify it. So plug in positive 1 for x. 2 take away 1 is 1, and 1 to any exponent is 1. So this is 1/2 times 4. So that simplifies to 2. Number 12, and again, press pause and try it. Follow along if you need help. Find the x values in which this function has horizontal tangents. So when I see the word tangent, it's telling me to take the derivative. So I'm going to do that first. So when I see the word tangent, it means derivative. When I see the word horizontal, it means the slope is equal to 0. That's the two things I'm getting. Take the derivative. That is 4x cubed. Subtract 32x. Take the derivative equal to 0, because the horizontal line has a slope of 0. Factor out a 4x. And then take each factor equal to 0 and find the x values where we have horizontal tangents. So one answer is 0. If I add 8 and take the square root, recognize when you solve a quadratic, the answer could be positive or negative. So that's one answer. These are two more answers. Those are all three. At those x values, the slope is 0, which means we have a horizontal tangent there. Find the equation of the line normal to this when x equals -1. So the equation of a line, I need to know what x equals, I need to know what y equals, and I need to know what the slope equals. So in the question it says x equals -1. To find the y value, just plug -1 in for x and simplify it. So that's -1 plus 1 plus 3. So that answers 3. And then the slope is found by taking the derivative. So the derivative of y is 3x squared, subtract 1, And then when you take the derivative, plug in -1 into the derivative. So if you plug -1 into the derivative, it simplifies to 2. What we just found was the tangent slope. So the tangent slope is positive 2. What's perpendicular to the tangent slope is the normal slope. So normal and tangent are perpendicular to each other. So take the tangent slope and do the opposite and the reciprocal. So that's why it's -1/2. And then put those numbers all together for the equation of a line. So the equation of a line is y equals the slope, -1/2, x plus 1, plus 3. And it's over. Number 14. Can you take the derivative implicitly of what you found? So implicit means x and y are mixed together. I can still take the derivative, but I need to remember the hook on y prime when I do it. X times y squared is called the product rule. So that's the first times the derivative of a second, but it needs the hook on y prime, plus the second times the derivative of the first, so the derivative of x, minus the derivative of -x, the derivative of 2y plus the hook on, and the derivative of 5. That's the hardest step right there. Remember the product rule. Remember the hook on of y prime as you go across. So x times 2y is 2xy, y prime. And we have a 2y prime. So we're going to gather together the y primes. If it doesn't have a y prime, it's going to move to the other side. So I'm going to add 1, and I'm going to subtract y squared, so it's on the other side of the equation. I'm going to divide out a y prime, or factor out a y prime, and then I'm going to divide to get my answer. And there's your answer. So when it's done implicitly, most of the time x and y will be part of the derivative formula. All right, turn the page. Number 15. In number 15, you're asked to sketch a curve given this information. F at x is continuous, so there's no breaks, no jumps. When I draw it, it's 1. Don't lift up your pen. We're given 2 points on this graph, 0, 0, and 2, 0. So I'm going to start there. And then we're given information about the derivatives. So we're told the first derivative is greater than 0 on this interval. That means it's positive. So I'm going to do a first derivative number line, and I'm just going to follow what it says. So it says from negative infinity up to 0, the derivative is positive. And then it says from 0 to 1, it's also, and from 1 to infinity. From negative infinity to 0, 1 to infinity, the derivative is positive. From 0 to 1, the derivative is negative. And I just found increasing and decreasing. And at 0, we created a maximum. And at positive 1, we have a minimum. So positive to negative creates a maximum. Negative to positive creates a minimum. We're also going to do a number line for the second derivative. In the question, it says the second derivative is greater than 0 for everything but 0. So it's concave up everywhere except at 0. And it says the derivative doesn't exist at 0. And because it's continuous, that means there's a cusp or corner there. And that's why the derivative doesn't exist. So then I'm just going to follow the number lines. So it increases and then decreases. So it's going to be concave up. Oops. So it smiles, concave up. It continues to be concave up. At positive 1, we have a minimum. So I need some point here that shows a minimum. At 0, we have a maximum. And everything is concave up. So concave up, concave up. We have a maximum at 0. We have a minimum at 1. Everything's concave up. It's continuous. And the derivative doesn't exist at that cusp or corner. Perfect. Number 16. Again, press pause, read the question, try your best, then press play. A rectangle is bounded by the x-axis in that curve. And you're given a graph of it. And you're asked to find what is the maximum area of that rectangle. This is called an optimization question. So I'm going to start with what's the formula for a rectangle. And you could either say length times width or base times height. And then I need to write that as a function of x. I need a formula for the area of that rectangle. So if I look here, I recognize the rectangle. We have an x coordinate and it's matched as a negative on the other side. But if I think of it as a positive value across here, how many x's make up the base? So I want you to get a sense that the base is 2x. And then what's the height of this rectangle? And that's the y coordinate. So everywhere where the y coordinate is creates the height. And in terms of x, the height is 5 subtract x to the 4th. So we create a function in terms of x that describes the area of that rectangle. I'm going to multiply this through. And then I'm going to take the derivative. So 10x negative 2x to the 4th. When I take the derivative and make it equal to 0, I'm finding the maximum value for the area. So that would be 10 subtract 8x. Oh, what's x times x to the 4th? That's 5. So then when I take that, it would be 5 times negative 2, then subtract 1 to the exponent, equal to 0. To solve this, factor out to 10. And then 10 has no solution, so actually you could have divided out 10. And then to solve this, the answer is positive 1. The answer could also be negative 1. But for this graph, we're just looking at the we're looking for this x value right there. And then I'm going to double it and then times the height. So the area is going to be found by, well, first of all, I need to test to make sure positive 1 is a maximum. So into the derivative, if I plugged in a half, that would give me a negative answer. And if I plugged in a number bigger than 1, like 1.5, that would give me a positive answer. Oh, wait a second. So if I plug in a half, it will give me a positive answer. And if I plug in a number bigger than 1, it's going to give me a negative answer. That's all I was looking for. This creates a maximum. So 1 gives me a maximum area. And then plug it back into the area formula from the beginning, and that will give you the area of this rectangle. So that ends up being 2 times 4. So the maximum area is 8. Number 17. In number 17, you have a function, and you have the intervals, and asked to find, using this function, can you tell me where it's increasing and decreasing, and show your work. So when you're asked about increasing or decreasing, you're asked to find the derivative. And so we're going to take and find the first derivative using the power rule. And then you take the first derivative equal to 0. So factor out a 6x and then solve it. So 6x gives you the answer 0. X subtract 1 gives you the answer positive 1. And then you have to draw a number line. And that number line includes 0 and 1, create your intervals for the derivative. And then we're going to plug in a number smaller than 0, any number smaller than 0. And I want to know if the answer is positive or negative. So I'm going to use the factored version. So that is 6 times negative 1, and negative 1 subtract 1. That's a negative times a negative, and that's a positive answer. So it's increasing up to 0. Pick a number between 0 and 1, like 1/2, and plug it into the first derivative. So if I plug in positive 1/2, I get 6 times 1/2, which is positive, and then 1/2 take away 1, which is negative. So a positive times a negative, that interval is decreasing. Then plug in a number bigger than 1 into the derivative. So positive 2, 6 times 2, 2 take away 1, all of it's positive. So now I have my intervals, so I know it's increasing from negative infinity up to 0, and it's also increasing from 1 to infinity using the number line. And then where is it decreasing is where the derivative is negative. And so it's decreasing from 0 to 1 is the interval where it's decreasing. How about concavity? How do I find it? So concavity is found by the second derivative. So I'm going to look at the first derivative and take the derivative again. So that's going to be 12x, subtract 6, make it equal to 0, solve for x, and you can reduce it down to 1/2 to make it easier. Draw a number line for that. This is for the second derivative. And then plug in a number smaller than 1/2, like 0. And if you plug 0 in here, you get a negative answer. If I plug in a number bigger than 1/2, like positive 1, gives me a positive answer. So that now told me concavity. This is a negative answer. That's a positive answer. So it's concave up from 1/2 to infinity, and it's concave down from negative infinity to 1/2. So this was so this was negative and this was positive. And then write it in interval notation. And then it says, where's the relative maximum? So if I look off the number line, when it goes from positive to negative, and it asks for the point where it occurs. So the x value is at 0 for the maximum. Plug 0 into this function. So 0, take away 0. All you're left with is 6. So there's a max at 0, 6. The minimum, when you go from decreasing to increasing, there's a minimum there. So that x value is at positive 1. And then plug positive 1 into the function. So that's 2 take away 3 plus 6. That's 5. So we have a minimum at 1, 5. The point of inflection is where the concavity changes, which is at 1/2. So I'll do the work for you here. You need to plug 1/2 into the function in the question. So it's 2 times 1/2 cubed minus 3 times 1/2 squared plus 6, and then reduce it down. So that's 2 times 1/8. That's 3 times 1/4 plus 6. This reduces down to 1/4, negative 3/4, 6. I'm going to write as 24 over 4. So we have common denominators. Put it all together and you get 22 over 4 or 11 over 2. So the point of inflection is at 1/2 and 11 over 2. All right, turn the page when you're ready. Now we're doing integration questions. Can you integrate with the power rule? So that means add 1 to the exponent and divide. And don't forget the candy. Don't have to reduce it down. Here, I'm going to write it calculus friendly. So I'm going to write 2 subtract 3x to the negative 2. There's a hook on here, and the hook on is negative 3. So I need the fraction negative 1/3, so it stays equivalent. Unhook this. Negative 1/3 is part of the answer. Add 1 to the exponent. Divide by negative 1, and then that makes it positive. So dividing by negative 1 makes it a positive 1/3, and it's done. Number 20. I noticed the monomial in the denominator. So I'm going to write this as 3 parts. So x cubed divided by x squared is just x. The x squares divide out, that's minus 2. And then 1 over x squared is x to the negative 2. So I have the ability to simplify this. Now do the power rule. So we add 1 to the exponent and divide. Negative 2 is negative 2x. Add 1 to the exponent and divide. And then don't forget the constant. Done. In number 21, this is called a definite integral. So for a definite integral, we have to do the antiderivative and plug in, or we have to graph. So for this one, I need to do the antiderivative. So to do the antiderivative, I'm going to write it calculus friendly. So that's to the 1/3. The antiderivative of this is to add 1 to the exponent. So 1 plus 3 is 4/3. And then the reciprocal, that's the antiderivative. And then the bounds go from negative 1 to 8, or the limit. And then the last step, and we won't simplify this, to plug in the upper bound, subtract the lower bound. So we have the upper bound, subtract the lower bound. Done. Good answer. So there's a definite integral. That's called the fundamental theorem of calculus. For number 22, when I have absolute value, I need to graph this. So to understand this as a graph, I'm only going to graph it from 1 to 7. I'm going to find the area under the curve to do the definite integral. So that's the second way to do it. One way is the antiderivative. Second way is by the graph. So for this one, you can see there's a beautiful light beam on my shirt. That's okay. I'm going to power through. So the graph here, plug in positive 1. 1 take away 3 is negative 2, and the absolute value of negative 2 is positive 2. 7 take away 3 is 4. So 7 gives you the answer 4. We also need the vertex. So if I take x subtract 3 equal to 0, there's a vertex when x equals positive 3. So then draw your v from that vertex. We have 2 triangles that we're going to find the area of. And that's going to give me the integration answer. So for the first triangle, the base is 2, and the height is 2. For the second one, the base is, from 3 to 7 is what, 4? No, right? 1, 2, 3, 4, right? 4. Don't overthink it. The base is 4 and the height is 4. So if I wanted to simplify it, it'd be half of 4, half of 16, put it together, and that answer is 10. All right, number 23. A function has a derivative. Find the function if its graph passes through the point 2, 6. So to find f at x, we're going to do the integration, the antiderivative of the derivative. So for this one, it would be add an exponent and divide. Negative 5 is negative 5x and then the constant. So that reduces, because we're in the middle of the question, we are going to reduce it down to make it easier. So it's 3x squared, subtract 5x plus c. It gives you that the it equals 6 when the x value is 2. So make it equal to 6 and plug in 2 for the x coordinate, and now solve for c. So that's 4 times 3. And just keep working and solving the question. Subtract 2, and you get c is equal to 4. And now solve it. Now take that and put it back into this. So my question was find f at x. So f at x is 3x squared, subtract 5x, and we found c. So it's 4. Done. In number 24, a region is bounded by x squared subtract 2. Start at negative 2. There's your parabola. And y equals negative x. There's y equals negative x. Shade the area in. It says shade. Excellent. Then it says find that area. How do you find the area between two curves? It's an integration question. So we integrate. What are my limits? Well, I got to make them equal to each other to find the limits. So I'll do that here. That's x squared subtract 2 equals negative x to find my limits. So I'm going to add x. I'm going to factor. And then once I add x and I factor it, the lower limit is negative 2. And the upper limit is positive 1. So I'm integrating from negative 2 to 1. And it's the top, subtract the bottom. So the top is negative x. Subtract the bottom, which is x squared, subtract 2. Make sure you use parentheses when you subtract so you don't forget to distribute. And now that's the setup. I actually have to find the area. So I'm going to simplify it. So this is negative x squared, negative x, and then a negative times a negative is plus 2. And then the antiderivative of that is negative x cubed divided by 3, negative x squared divided by 2, and 2x. And I'm integrating from negative 2 to positive 1. So first I plug in the upper limit, positive 1. I don't have to simplify this. And then I subtract, use parentheses, and then do the same but put negative 2 in. So you plug in positive 1, subtract the lower limit of negative 2. Don't need to simplify it, and there's your answer. All right, press pause, turn the page, look at it, and then press play. '25. Find the average value of this from 0 to 6. The average value is an integration question. So there's the setup for average value. You integrate from 0 to 6 and divide by the difference of the bounds. If I want to integrate this, right, write it calculus friendly. There's a hook on of 2. So I need a 1/2 in front of the hook on. Now to make life easier, that 1/2 and 6 together make 1/12. The 2 is unhooked, and then you do the power rule. So you add 1 to the exponent and divide. So if I add 1 to the exponent, that's 3/2. and then the reciprocal. And I'm integrating from 0 to 6. So this reduces down to 1 over 18. And then I'm going to plug in 6 first. Don't be complicated. Just plug in 6 and don't simplify it. And then subtract and plug in 0. Now 0 does not give you the answer 0, so you still have to actually do the work. And there it is. For number 26, again, press pause, look at it, think about it, try your best, then press play. The sketch at the right shows the graph of this, and it says, set up but don't integrate an integral for the volume formed by revolving the region. Now the word revolving means it's going to be a circle. And we're revolving it around the x-axis. So is this a disk or is this a washer? So the x-axis, it's touching the line of revolution all the way through the interval. So therefore it's a disk. And there's only one circle. So what's the setup? Pi r squared. And it's around the x-axis, so it's dx. What are the limits? And it goes from 0 to 1. And then what represents that radius is the curve. So like top, subtract bottom is 0. So just that curve is the radius. And that is x to the 4th minus the square root of x plus 1. So I don't need to do anything more than that. That's the setup for a disk. Over. For number 27, a different question altogether. So a solid with square cross-sections perpendicular to the x has a base region bounded by that. Show and sketch the area of the region from 0 to 3. So if I plug in 0, I get 2, so I'm going to go there. If I plug in positive 3, I get the square root of 3 plus 1. So I'm going to plug in 4 instead. So the square root of 4 is 2 plus 1, so it's 2/3. So if I go one more to 4, I get 2/3. So in other words, it's a curve that looks like this. And then I am going from 0 to 3. And we have y equals negative 1. So that is the area that we're talking about. So you have the curve, x equals 3, y equals negative 1. That's x equals 0 shaded in. So the question is, what's the volume using square cross-section? So 1 square, that's going to be the base of that square, top, subtract bottom. So the top is this, subtract the bottom, which is negative 1. So that's top, subtract bottom. So the setup then is an integral question. The lower limit to the upper limit. So that's 0 to 3. The formula for a square is take the base and square it. So I'm just going to plug that in. And it's done. That's the integral setup to find the volume using square cross sections. And then it says use your calculator to integrate it and give your answer. So let's do that. So now let's use your calculator. I'm going to clear this. Press menu, calculus, integrate, and we're going to integrate from 0 to 3. We are going to use parentheses. We're going to go control divide to create a fraction. 2, the denominator is the square root of x plus 1. Move the cursor. We're going to add 1 to that. Move the cursor. We're going to square it. Then dx, and then control enter. I know it gives you a caution sign. Ignore it. So because there's a domain restriction for this, but from 0 to 3 there's no domain restriction. So there it is. That's the volume 11.6 784. All right, last part before the sun takes over my head. Here we go. This will be a quick question, I hope. Natural gas, there's like a graph of it. And it says if f at x is the function for that rate, decatherms per month, it doesn't matter. If f at x is the function shown before, from 1 to 4, if you integrate, the answer is 41. So if I find the area from 1 to 4, that area is 41. Write a sentence saying what this means in words. So understand 1, when t equals 0, it's January 1st. When t equals 1, it's February 1st. So from February 1st to, now when x equals 4, be careful. So as we think of this through, April, it goes to May 1st, right? So from February 1st to May 1st, what happened? So if you think of this, include numbers and units. And so the rate is decatherms per month. And so a total of 41 decatherms, I don't even know what that is, was used. So from February 1st to May 1st, a total of 41 decatherms was used. When you integrate a rate graph, it's an accumulator. So how many decatherms was used from here to here? That's a good sentence. Number 29, this is the fundamental theorem of calculus. Part 2, the sequel. The derivative and integration, they undo each other. It's a substitution question. But be careful. When you plug 5 in and take the derivative, the answer is 0. Then the bottom limit, plug it in. And you have your answer. But that negative is essential because you're first plugging in 5 and then the derivative, then you plug in x. There's no hook-on factor because the derivative of x is 1. And that's it. You finished it. I'm so proud of you that you're doing your work. This was the most difficult assignment yet. All questions from units 1 through 6. And you did it with me. So awesome job. Until next time.